Okay, so in this equation, this problem, we have these two equations, and we are trying to basically get one of the letters to eliminate. Doesn't matter which ones. You can do the X's or the Y's. So I'm gonna, on this one, so you just basically, that's how you start these problems. You always start and you look at the two X's, you look at the two Y's, and you ask yourself, how could I make either the X's or the Y's opposites? You want to make them opposites so that when you add them, that letter will cancel, become zero, and go away. Because you want to get rid of one of these letters because you don't want both letters. We can't handle both letters at the same time. We want to get one of them to drop out so that we only have one letter left, and then we can solve for that letter that remains. So we've got to get one letter to cancel out, eliminate. So to do that, we got to make them opposites. So I'm looking right here at these Y's. These look a little easier than the X's. I can make this 3. If I multiplied it by 2, I could make it 6Y. Then it'll be the same as the bottom. Oh, but I want to make it opposite. So multiply by -2. Then it'll be -6Y, which is the opposite of positive 6Y. So there's what I want to do. I'm going to take this top equation here, and I'm going to multiply it by -2, because I know when that -2 multiplies, and whenever you multiply, you got to go all the way, both sides of the equation, left side and right side, And so you'll get plus 12x minus 6y equals plus 66. Right? So see how that made a minus 6y, which is going to be the opposite of the plus 6y. So I'll just bring over the bottom equation. Minus, no changes to it. There's that plus 6y, which is the opposite. All right, we did it. Now we add these up, and x's eliminate. Oh, wait a minute. They both eliminate. Look at that. And this side too. Everything eliminated. We just focused on the y's and made them opposites, but lo and behold, everything became opposites. What does that mean? Well, when both letters cancel, that's what's just happened here, right? Both letters have canceled. There's two possible scenarios. Number one, you get 0 plus 0 equals a number that's not 0. Like 0 plus 0 equals 8. That is not true. Right? 0 plus 0 does not equal 8 or whatever number you have over there. So that means no truth, no solution. That would be no solution, but that's not our case, is it? Our case is 0 plus the second possibility when both letters cancel is you get 0 plus 0 equals 0, which is true, right? So you're going to have answers, right? This 0 plus 0 does equal 0. It's a very simple truth, but it is true. So it's not true, to use double negative there, right? So therefore you have the other case, infinite solutions. Our answer is infinite number of solutions. Because there's truth. So when there's truth, there's answers. Math is always solving things to make them true. Math is always solving to find out what is the truth. So here's how you remember this. Well, you can use your notes during the exam, but also if you get 0 plus 0 equals 8 or something like that, that's not true, no solution. So if you get a statement that's not true, like 0 plus 0 equals 8, that's not true. No truth, no solution. But if you get something that is true, like 0 plus 0 equals 0, that's true, infinite solutions. And in fact, let me show you from the notes. Got something here. Let me go to the notes for you. The chapter 5 notes. There we go. Yeah. So in the chapter 5 notes, I've got something to help, a nice little summary table I found. Here we go. So here's also from the chapter 5 notes that you can use during the exam. I've given the 3 different categories. So using the addition method, If you get 0 equals 0, is what we got. That's what? Infinitely many solutions. If you get 0 does not equal 0, like you get numbers that are not equal, then that's no solution. But we got 0 equals 0, infinite solutions. And that's the same thing as when you get two lines that are right on top of each other. It's nice. This little table I found is nice. Connecting the graphing method, the substitution method, and the addition method. How the results will look for infinite solutions, how all three results will look for no solution, and how they look when you just have one solution. So there we go. Ours is infinite solutions.